Hi, in the previous video, we talked about the oxidation numbers and the ionic bond. In this video, we're going to talk about the Lewis structure and covalent bond. This is Dr. Najib Balfakih. Our objective in this video, we're going to talk about the valence electrons, identify the type of bonds, draw the Lewis structure, and we're going to talk also about the exceptions. So in chemistry, the valence electrons are the one that we care about. In group number one, it's including like hydrogen, sodium, potassium, rubidium, cesium. The only thing that we care about how many electrons in the valence electrons. And in group one, always we have one electron. Group two, we're gonna have two electrons. Group 3 or 13 will be 3 electrons. Group 14, it will be 4 electrons, including carbon. Group 15, which including nitrogen group, it has 5 electrons. Group 16, which is including oxygen atom and sulfur, it has 6 electrons. And halides, which including fluorine, chlorine, bromine, iodine, it has 7 electrons. Also, we're going to follow the octet rule, as we did with ionic bonds. So we're going to follow the octet rules, and the octet rule, to remind you, atoms like to have 8 electrons, and the valence electrons, except hydrogen, it needs only 2 electrons. So this is the definitions. We have single bond, so we're going to have sharing of 2 electrons to create a single bond, and double bond, so each atom will share 2 electrons, and the total will be 4 electrons to create double bond, and the triple bond, each atom we're going to share with 3 electrons, and the total will be 6 electrons to create triple. To draw the Lewis structure, there are 7 steps. We're going to count the total valence electrons of all atoms that involve in the Lewis structure. Then we're going to distribute the central, or choose the central atom, and the central atom is the one which has the least electronegative. We're going to talk about it, which is the ability to attract electrons. Then connect atoms with a single bond. Then distribute the remaining electrons. The fifth step, check for octet rule. If still each atom has not reached octet or 8 electrons, then we're going to create the double bond. If it works, that's fine. If still you need more electrons, you create the triple bond. The final structure, all atoms should have 8 electrons around it. You see in this slide, there are 3 examples. You have hydrogen bonded to another hydrogen, fluorine bonded to another fluorine, and chlorine bonded to another chlorine. I will explain at least one of them in the next slide. As you know, hydrogen, it is in the first group, so it has 1 electron, and also bonded with another hydrogen, as we said in the previous video. Hydrogen needs only 2 electrons to be similar to the electron configuration of helium, so they're going to share each other, and this is the bond. we're going to count the electron of each one of them. So this hydrogen, it has 2 electrons now, and the other one, it has also the other 2 electrons. So both of them are happy. If you want to see fluorine, let us see fluorine. Fluorine, it is in the 7th group, so it has 1, 2, 3, 4, 5, 6, and 7. The other fluorine, it has 7 also electrons. So we have the other electron. So 1, 2, 3, 4, 5, 6, 7. Now this fluorine needs 1 electron, so we're going to share, take that electron from the other fluorine. Now this is going to be, sorry, I'm going to draw it again, sorry. 1, 2, 3, 4, 5, 6, 7, and other one, 1, 2, 3, 4, 5, 6, 7. So they're going to share the electron. Now we have single bond. So this fluorine, it has 8 electrons, and the other one, it has 8 electrons. So both of them are happy. Another example of a single bond, water, ammonia, and methane. I will give an example of ammonia, for example. Ammonia, you have nitrogen. It has 5 electrons. 1, 2, 3, 4, 5. Remember, ammonia is NH3. So it has hydrogen, 1, hydrogen, 1, and now look at this, each one of them. Hydrogen is only 1 electron, so shared, and also all of them, sorry for that. So now hydrogen here, it has 2 satisfied, and this is 2, and this is 2 electrons. What about nitrogen? Nitrogen you have 1, 2, 3, 4, 5, 6, 7, 8, and also ammonia is the same thing. If you want water, water it has the 6th group, 1, 2, 3, 4, 5, 6, and it is bonded to 2 hydrogen. So now it has, this is the single bond, and if you count how many around oxygen, 1, 2, 3, 4, 5, 6, 7, 8, and also hydrogen is satisfied with 8 with 2 electrons. We're going to see other examples with carbon dioxide and cyanide HCN. We have ethylene and also acetylene. I'll go with carbon dioxide. Carbon dioxide, sorry. Remember, carbon, it has 4 electrons. Oxygen, it has 6, so 1, 2, 3, 4, 5, 6, and another oxygen, 1, 2, 3, 4, 5, 6. Now we're going to create the single bond. Now let us check for octet rule. Oxygen, it has 1, 2, 3, 4, 5, 6, 7. It's not acceptable. The same thing, oxygen, the other oxygen, has 7 electrons. And what about carbon? 1, 2, 3, 4, 5, 6, 7. So this doesn't work. Let us move this electron and this electron to here. What about this electron? Also move it to here. And this electron gonna be moved to here. So we're gonna create double bond. So it will be double bond and also double bond CO2 now. If you count how many electrons around each one of them, it will be 8. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Also the carbon 1, 2, 3, 4, 5, 6, 8. By the way, the carbon makes 4 bonds. Nitrogen makes 3 bonds plus 1 pair of electrons. Oxygen, as you see here, makes 2 bonds plus 2 pair of electrons. And we have the hydrogen and halides, fluorine, chlorine, bromine, iodine, always at the end of the compound. So this is Dr. Balfakih. Hopefully you learn how to create, to draw the Lewis structure, and from there you can create covalent bonds.